Hello guys, a very good morning. Welcome back to my YouTube channel. Today we are continuing the electrical load calculation part. In last 2-3 videos I have covered around 11 subtopics. Today we are starting with the 12th topic, that is transformer sizing. As I have already explained in last video that usually we will get load in kilowatt, but all the equipments like transformer or DG, they are available or they are rated in kVA, not kilowatt. So what we have to do for that one, we have to convert kilowatt into kVA. How do you do? Kilowatt divided power factor is equal to kVA, right? For example, you can see on screen that is your maximum demand load is 160 kilowatt, power factor will be 0.9. So you will end up with 177.7 kV. We will go for next size. Always you have to go for next size, that is 200 kVA you are taking. Along with this, you have to consider 20 to 25% spare. For any equipment you have to consider. It's must and should. Then again loading. You cannot run your transformer 100%. Why? Because if you load your transformer, if you run your transformer to the 100%, core losses will be there, then temperature rise will be there, winding insulation may fail because of this. So these are the disadvantages of having transformer 100%. So you always load transformer 80%. Then standard sizes will be the 100 or 60, 200, 250, whichever is near to your value, that higher size you have to take that value. Then 13th, that is DG set sizing. It is also same as transformer sizing. Only difference is the power factor you take, not power factor, the diversity factor you take, the capacity is matter here. For residential it is 100%, then commercial or office area it is 80 to 100%, then hospital or IT or DC it is 100% critical because it is critical. Then industrial process it is 100%, firefighting pump you take, it is very so it is 100% dedicated. Then formula will be DG kVA is equal to essential load divided by power factor. That's it. It is also same as transformer sizing. Then come to the 14th topic, that is cable sizing. Very important topic it is in electrical system design. Why? Because you will have equipment, you will get the kilowatt rating, everything. But how do you pass the current? It's through cable only. That's why it is very important the how you size, how accurately you size the cable. So how do you do? You will end up with the kilowatt. Accordingly you will calculate current. That how to calculate current is also being covered in last session. So please go through it if you are not go through it. Then there will be one standard chart. If you want, I will give you that chart. It will be having current carrying capacity of that particular cable, its diameter, its resistance, it gives like its insulation level, everything will be written there. So current carrying capacity you will get. See, on the basis of your current requirement, you will just randomly select one cable. You check for whether its current carrying capacity is matching with my requirement or not. That current carrying capacity is nothing but it is not denoted as a J. That is J is equal to I divided by A. Means how much ampere it can carry per square meter of area. You will get that current carrying whether if it is above your or near to your requirement, you will go for that cable, or else you will go for other size. Then after selecting that cable, you have to check for voltage drop. Voltage drop calculation is also I have covered in last video. Please go through it. That voltage drop value should be less than or equal to 3% for lighting circuits, and it should be less than or equal to 5% for power circuit. Then short circuit withstand capacity also you should take care while sizing the cable. It should withstand the short circuit value at that particular location or at that particular system. Ambient temperature factor also you should consider. Why? Because if you take a cable at the location where temperature is more, that after derating, the current carrying capacity of that cable is going to reduce. That's why you have to consider this also. After derating value, it should match your requirement. Then grouping factor is also very important. In detail I will cover in upcoming videos for these topics. Then VD formula, it is given here. Then come to the 15th topic, that is cable current carrying capacity. In general it is given, but it is going to differ depending on the insulation, whether it is PVC insulated or XLPE insulator, or whether it is copper cable or aluminum cable. Why? Because copper has more current carrying capacity than the aluminum. So be careful while selecting the cables and its withstand current carrying capacity. Suppose for example here you take 1.5 square mm it is there. If you take through conduit, its current carrying capacity will be 15 ampere. If you take it through tray, it will be 18 ampere. Why the difference? Mainly because of the conduit will be closed. There will be no ventilation for the cable. Temperature will increase there. So that is the condition. But in cable trays we will have sufficient ventilation for cables. That's why the current carrying capacity difference you can see. It is same for all the it is given same thing for all different types of different sizes of cables. You please go through it. Then come to the 16th topic, that is circuit protection devices. See here, there are 2-3 different types of circuit breaker are available. One is MCCB, first is MCB, then MCCB, then RCCB or RCD. We can call it ELCD also, we call sometime ELCB, then RCBO, ACB, SPD. MCB means miniature circuit breaker. Up to 100 ampere we use MCB. It is mainly for overload and short circuit protection. We use MCB. In detail for this circuit breaker, how it works and how it protects overload and short circuit, that I will cover in upcoming videos. Then MCCB is also for overload and short circuit, but up to 100 we use MCB. After 100 we go for MCCB, and there will be trip setting is, you can set the tripping value, tripping settings, seconds, tripping value. That setting is available with MCCB, not in the MCB. That is the difference between MCB and MCCB. Then RCCB is mainly for earth leakage protection. Up to 30 milliampere, or some cables are available with 100 milliampere also. Usually we take 30 milliampere. So RCCB is for earth leakage. Then RCBO, it's a combination of MCB and RCCB. Residual current circuit breaker overload, it is overload plus earth leakage. Even it is for short circuit also. Then ACB, that is also for overload and short circuit, but it is used as a main incomer. After all, I said already that up to 100 MCB, above 100 MCCB, till 630 we use MCCB. After 630 we go for ACB. Then SPD. SPD will be, it's for surge protection. We use SPD. Then come to the 17th topic, that is lighting and power circuit guidelines. Like some standard guidelines are there, you have to follow while doing lighting and power circuits. See, if you take one circuit from DB, that suppose R1, if you take, that limit will on that circuit will be maximum, it should be 800 watt or 20 points, 20 lights you can take, maximum 20 points or 800. Then lighting cable will usually we take 1 square mm copper only, and MCB of 6 ampere or 10 ampere. Then for 5 ampere or 6 ampere socket cable, it will be 2.5 square mm MCB, 16 ampere. And if you go for AC or geyser, it is depends. Why? Because it depending on the capacity of that equipment. Whether sometimes we use geyser of 2005 ampere, sometimes we use 7000 kilowatt. So depending on the kilowatt of that particular AC or geyser, we will select the circuit or cable size. Then heavy power, it depends on its value. MCB rating, always next standard, above load. This is all about today's topic. Please go through the video, and if you don't get anything, if you feel difficulties at any time, please do comment in the comment section. I will clarify your doubt. Thank you. Please subscribe to my YouTube channel, like, share and comment below. Thank you.